Let us discuss the time complexity of Quicksort algorithm. The heart of Quicksort algorithm is the partition function. The partition function will pick one element of the array as the pivot element. Then the array will be divided into two. All elements on the left subtree are less than or equal to pivot element, and all the elements on the right subtree are greater than or equal to the pivot element. Suppose this is our array, some 300, 150, 2, 20, 30, 25, some 3. Okay, and we are picking 20 as our pivot element. So based on this value, the array will be divided into 2. All the elements less than or equal to 20 will be on the left subtree. They are 2, then 3. These are the elements less than or equal to 20, and all the elements greater than or equal to 20 are gathered on the right subtree, that is 300, 150, 30, 25. Okay, these are the elements greater than or equal to 20. So this means we have placed the pivot element in its correct position. Okay, so remaining elements are arranged on the left subtree and right subtree. Remember, on right subtree all the elements are greater than or equal to pivot element, and on left subtree all the elements are less than or equal to pivot element. So here we will call the Quicksort algorithm again on left subtree and right subtree. Let us consider the right subtree. Suppose we have picked 30 as our pivot element. So based on the 30, this array will be divided into 2. 25 will be here, and 300 and 150 will be here. Okay, this is the case. Next, let us see what is the best case complexity of Quicksort algorithm. Best case complexity of Quicksort algorithm. In the best case, the selection of pivot element divides the array into exactly two forms. Suppose there are n elements, the array pivot element divides the array into n by 2 left side and n by 2 right side. For the problem size is n by 2 here and n by 2 here. We will call Quicksort again. It will divide n by 4, n by 4, again n by 4 and n by 4. Okay, this will continue. In general, we can say it is n by 2 raised to k, n by 2 raised to k. That is the problem size is n by 2 raised to k at some level k. This is level 0, this is level 1, this is level 2. Here you can see the problem size is n by 2 raised to 2. So in general, the problem size is n by 2 raised to k, and finally the problem size will be reduced to 1. And this is similar to the recursion tree of our merge sort, and in total number of levels will be log n plus 1 if n is equal to 2 raised to some k, n equal to some 2 raised to k. Then on each row, intermediate rows, the partition happens. This partition happens, and the cost of partition is c into n, because the partition can be done using a single row. So the cost of partition is equal to c into n, For the complexity of partition function is theta n. Then what is the total cost of this tree? This recursion tree is similar to the cost of similar to the recursion tree of Quicksort. We already learned the analysis of the recursion tree of Quicksort. We can apply the same here. Since there are log n plus 1 levels and the cost of partition is C into n, so cost is Cn here. Here 2 into Cn by 2, the cost will be Cn. Okay, so total cost Tn is equal to Cn into log n plus 1 is equal to Cn log n plus Cn. Cost is Cn log n plus Cn. You can say the complexities, you can see n a term n log n is coming, so you can say the cost is n log n. The cost is the complexity is big O n log n. Okay, the total cost is Cn into log n plus 1. The complexity is big O n log n. This is the best case complexity of Quicksort algorithm. Next, let us check what is the worst case complexity of this algorithm. We already discussed, based on a pivot value, the array will be divided into 2. Suppose we are picking the smallest element of this area, that is on this subtree, that is 25 as the pivot element. Then what will happen? All the elements less than or equal to pivot element will be gathered on the left subtree, and all the elements greater than or equal to pivot element will be gathered on the right subtree. Here there are no elements less than or equal to 25, so all the elements are gathered on the right subtree, that is 300, 150 and 30. Okay. Then in this subtree we are selecting 30 as the pivot element. Then this will be the next level. All the remaining elements will be gathered on the right subtree. Okay. So in the worst case, the remaining elements will be gathered on the right subtree if we pick the smallest number as the pivot element. If we pick the biggest number as the pivot element, then the array will be all remaining elements will be gathered on the left subtree. Suppose 300 was the pivot element, then all the remaining elements are less than 300. So it will, they will be gathered on the left subtree. Okay. So you are getting a left skew subtree or right skew subtree. Okay, that means if there are n elements, we will be picking one element as the pivot element and dividing the array. That means we have placed the pivot element in the correct position. Our task is arrange the elements in the ascending order or descending order. we will be picking one element as the pivot element, then placing it in the right position. Then only we will be getting all elements left are less than or equal to, and all the right are the elements on the right subtree are greater than or equal to. That means we have placed the pivot element in the right position. Okay. In this case, we can say 20. Its position is 2, 3, 20, 300, 150, and 24. This is the position of 20. It is in the right position. Okay. So in the sorted arrangement, this is the position of 20. So in the worst case, we will be picking the smallest element or the highest element as the pivot element. Then the elements will be used on left or right subtree. Suppose this happens, place the pivot element in the right position, then remaining n minus 1 elements. At this level, at this node, we have picked one pivot element, placed it in the correct position, then the remaining elements are gathered on the right subtree. Okay, and this continues. Finally, problem size will become 1. Then what is the cost of partition here? It is Cn. At this node there are n minus 1 elements, that is problem size is n minus 1, cost will be C into n minus 1. Here the cost will be C into n minus 2, like that. The cost will be C into 1. Then what about total cost? Total cost Tn equal to C into 1 plus 2 plus 3 plus n minus 2 plus n minus 1 plus n. This is equal to C into 1 plus 2 plus 3 plus n minus 1 plus n. What is 1 plus 2 plus 3 plus up to n? N into n minus 1 by 2. Sorry, n into n plus 1 by 2. It is n into n plus 1 by 2. You will be getting some n square terms here, isn't it? C equal to C by 2 into n square plus n. So you are getting Cn square by 2 into Cn by 2. We can say the complexity is big O n square. So this is the worst case complexity of Quicksort.